In the midst of the Cold War and behind the impenetrable curtain of the Iron Curtain, the Soviet Union secretly guarded its space ambitions, with Mars as a destination in its sights. Unlike NASA's transparency and open media relationship, Soviet missions were carried out in the strictest secrecy. Only a privileged few were aware of the Soviet efforts that would catapult them to unprecedented heights in the space race. In a turn of events, NASA has recently revealed previously classified evidence suggesting that the Soviets did manage to land on Mars. This find raises intriguing questions. Why did the Soviet Union initially choose to hide these missions? How many attempts did the Soviets make to reach Mars? The Cold War, defined by an intense ideological and political rivalry between the United States and the Soviet Union, generated technological progress that propelled humanity towards the stars. The space race, a vital component of this era, exhibited geopolitical competition and led to a remarkable era of scientific and technological advances. After facing hard times and problems, the Soviet Union seemed to be winning the space race, while the United States had disappointments, such as the launch of Sputnik and the flight of Yuri Gagarin. The road to the moon was not all about success, as there were also challenges, such as the fire at Apollo 1. Despite this, the U.S. Apollo 11 succeeded in reaching the moon, with an exciting live broadcast that captivated millions. Meanwhile, Soviet scientists were secretly working on an important project, even bigger than reaching the moon. They wanted to send a human to Mars, a goal that, if achieved, would have been a major milestone in space exploration, long before the current plans of the likes of Elon Musk. What were the beginnings of these plans, and why did it take decades to be known? In short, no one wants to admit mistakes, especially a superpower in the midst of the Cold War. The fierce competition between the United States and the Soviet Union spanned many arenas, not just conflicts like in Korea or Vietnam. This led to the Soviet Union hiding problems and failures. In 1960, 9 years before Apollo 11, Soviet scientists already had Mars in mind as an exploration target, beyond the moon. They launched missions in the 1960s to explore Mars, which marked a milestone and paved the way for future expeditions. Mars is unique in the solar system, with a rotation of 24 hours and 37 minutes. An orbital inclination similar to Earth. It has seasonal changes and evidence of a past with water and vegetation, which makes it even more intriguing. The Soviets had a program called Mars to explore Mars with unmanned missions. The first mission, Mars 1, lifted off in 1962 from the Baikonur Cosmodrome in Kazakhstan. It used the Molniya 8K-78 rocket, an improvement on the R-7 Semyorka missile. Mars 1 was an automatic interplanetary station that sought to fly over Mars, being the first to do so. He wanted to obtain data about the space between Earth and Mars, explore Martian magnetic fields, and take images. The ship was cylindrical in shape with solar panels and antennas for communication. A major problem occurred on March 21, 1963 during their trip to Mars. Communication was cut off due to faulty sensors that consumed power. Mars 2 and Mars 3 were also lost at launch. In 1971, the USSR moved forward with the M4 program, which included Mars 2 and Mars 3. The United States launched Mariner 9. The Mars 2 and 3 missions wanted to land softly on Mars. They used identical ships with orbital and landing modules, plus a rover. The landers would take images and data from the surface. Mars 2 was launched in May 1971 and arrived on Mars in November of that year. About 4.5 hours from reaching Mars, the spacecraft released the lander, but a problem occurred. The module entered the Martian atmosphere at the wrong angle and speed, impacting before activating the parachute. It crashed in a specific place. The orbiter adjusted its orbit and activated its instruments near Mars. Mars 3, part of the USSR's Mars program in the 1970s, had an orbiter and a lander. The module landed in December 1971 and transmitted images to Earth, but lost contact. It was suggested that a dust storm caused signal loss, similar to war situations. Mars 3 provided data about Mars, such as low pressure and cold temperature. The Mars 3 orbiter had fuel problems and had a different orbit. He was also carrying a small rover called Prop-M, which explored Mars on skis to avoid trouble. Despite being simple, the rover's test was successful. Upon landing, Mars 3 successfully freed the rover and continued on its intended path. After an hour of nervous waiting, they finally received a signal, but had to adjust its intensity. The data showed a gray image with no clear detail, and the signal disappeared in 14.5 seconds, mystifying the team. After discussions with scientists and engineers, Permanov examined the image again, concluding that a dust storm had disrupted communication with Earth. This terminated the Mars 3 mission, deeming it successful. On February 10, 1974, the Mars 4 orbiter was launched and reached Mars. However, a transistor failure affected its performance, and the braking rockets failed, causing it to pass close to Mars. Despite that, it captured images and radio data, revealing details about the nighttime ionosphere of Mars. It then continued to transmit data from an orbit around the Sun, attempting to approach Mars again on February 12, 1974. Mars 5, launched in August 1973, managed to reach Mars and enter a 35.3-degree inclination elliptical orbit. Their cameras could take 12 photos at each approach. It collected data on 22 orbits before losing pressurization on its transmitter. Mars 6, launched in August 1973, reached Mars in March 1974, but lost contact during descent. It landed on Margherita for Terra, transmitting atmospheric data, though much of it was unreadable due to component failure. Mars 7, launched in August 1973, arrived at Mars in March 1974, but ran into problems with its systems and passed close to the planet earlier than planned. How did the Soviets handle this situation? Although they hid the launches as state secrets, more space missions were known. To hide failed missions, they called them Cosmos or Sputnik, and sometimes disguised them as Earth satellites. The Mars 2 and 3 missions generated mystery in 1971, only revealing the successes of the orbiters. The truth was not known until the 1990s. The Soviet Mars program had little success, with only one probe having relative success. The others faced problems. In 2007, an image of Mars reignited interest in searching for remains of Mars 3. In 2011, it was claimed to see remains of the parachute, but the fate of the rover remained unclear. Although limited, the Mars 3 mission provided valuable lessons for future exploration, improving our understanding of the challenges in studying Mars. Mars has been a major focus for NASA for decades, attracting scientists for its geological history and the possibility of extraterrestrial life. Upcoming missions to Mars, such as the Sample Return mission, mark a milestone in planetary exploration. This collaboration with ESA plans to bring samples from Mars to Earth for detailed analysis. The Mars 2020 rover Perseverance paved the way, collecting samples for its return. A lander will carry an ESA rover to collect the samples, launched by a small Martian rocket. Finally, an orbiter will bring the samples back in a complex but exciting process. Once on Earth, the samples will be available to scientists around the world in advanced laboratories. The analyses will go beyond what the rovers and instruments on Mars can achieve. The resulting data will offer valuable insights into the history, geology, and possibility of past life on Mars. The Mars Sample Return mission is a transformative step in our quest to understand this neighboring planet. Despite notable failures in the Soviet Mars program, his efforts laid a solid foundation for future exploration. Lessons learned fueled technological advances and a deeper understanding of interplanetary travel, strengthening our spacecraft and increasing confidence in Mars exploration.